Okay, so first of all, welcome to this course. This is Intro to Java. This course will be going through a lot of material, but basically we're going to be teaching you object-oriented programming using the Java programming language. Now, there's going to be a few tools that you're going to have to use. Obviously, Classroom is where most of our materials will be posted, but you'll have something new to a lot of you called Runestone. Runestone's this awesome website. It's got tons of free programming textbooks, and I'll help you sign up for it in class. So if you're having trouble, don't worry about it. But basically, in this, think of this as like our workbook. Now, the CS Awesome runestone that we're going to be using is directly aimed at the AP exam. We won't be doing the AP exam, so we're going to be skipping some sections that aren't as important. Like we're going to be skipping basically the whole first section, talking about the differences between the AP exams, for example. But I just want to give you a rundown of what the pages look like and what you should expect, and then get into the lecture itself. So the first part is we are always going to have like an introduction, and there's a video lecture. So in case you think my video lecture is not that great, you'll have another teacher who's usually an expert teacher or a professor giving a lecture on the same topic. You do not have to watch these, but if you want more experience, they're very good to watch. Okay. All the definitions and readings will also be reiterated here in a different way than I'm doing. Okay. And then there will be problems. So some of them are just going to ask you to like run it and see what it does. So it'll run my code here, and it'll tell me if I got the expectation. Sometimes you'll have what's called a Parsons problem, which you need to public and void main string. You need to drag out the correct answer and then check it. Okay. If you get it wrong, on purpose, it'll tell me it's wrong. I can even try to reset it and try again. Okay. So you have a whole bunch of workbook problems. These first ones are just trying to teach you Java's syntax. We'll get to that again in my lesson here, but I want you to have everything as far as the course goes. Same thing here. We drag things out. They're just bigger versions of the same idea. I'm trying to see if there's anything else here. These are codes we have to fix. Quick review. And there'll be AP practice questions. I still want you to do the AP practice questions because it'll let you know if you could pass the AP exam. Okay? So every chapter, basically, I'm going to do a lecture. And my lecture is going to correspond to so many sections from here. I'll tell you the exact sections to do. And I'll have some questions and some worksheets for you to do. We'll always have a lab, and we will have a test to go with that as well. So anyway, so why programming? Well, you guys signed up for computer science, and computer science and programming are not the same thing. It's a common misconception, but they are not the same thing. So basically, most universities start you, if you take computer science, your first year is going to be a lot of math courses, usually calculus 1 and 2, and you're going to take at least 2 programming courses. Most of these universities will teach you in Java or Python. A few like UCL, I think, does Haskell. Brown does Pirate. And some PhDs disagree with this because it makes people think that computer science is not programming. Well, this might be true, but programming is a place where we can practically apply what computer science is, which is the skill of developing algorithmic thinking. So being able to think of things in steps, how to solve things, how to break problems into smaller steps. So just a quick reminder for computer science. A computer is a machine that manipulates data and executes a list of instructions known as programs. The key difference is versatility. Computer science A, we spoke about a general computation machine. We also spoke about NAND and binary and how a computer works on a physical level. If you need to review any of that, I have no problem giving you the material, especially if you're going to do the AP exam. But if not, I'm not going to focus on those as much in this course because we're going to focus almost purely on algorithmic thinking. And to do that, we're going to use Java. Java was invented in 1995 by Sun Microsystems. and they defined Java in a white paper. They said that Java is a simple, object-oriented, network-savvy, interpreted, robust, secure, architectural, neutral, portable, high-performance, multi-threaded dynamic language. Whole bunch of mumbo-jumbo, but what does that mean to me? Well, first of all, we're going to have to use an IDE to use Java. So a lot of you are familiar with Code.Pirate. If you did Python before, if you're on Vex, you might be familiar with VS Code. Okay, VS Code can do Java, by the way. I just don't like it to start with because it's not made for Java. So at the start of the class, we're going to use something called JGrasp. JGrasp is a very basic IDE. It's very lightweight. It's only like 7 megabytes, and it just does everything automatically for you. Later, we'll move to IntelliJ, which is a Java IDE from JetBrains, which is the most used professional one. Whenever we move to IntelliJs, if you're comfortable with VS Code, you can stick with VS Code, but I'm going to go with IntelliJ, in case you take Computer Science C, which is going to probably be based around Android. Anyway, so why are we focused on Java? Well, first of all, Java is object-oriented. You don't know what that means, most of you probably, but that's okay. That's the point of this course, is to teach you object-oriented programming. In Pirate, we taught you functional programming. Secondly, Java is very popular. It's still in the top 3 or 4 top popular languages. It's a good place for beginners to learn. The AP and IB exams are based on Java. So by doing this, if you want to do the AP as a homeschool student, you can do it very easily. And again, just because the rest of the school is IB, we're going to be IB-ish in a couple ways I'll explain later. Java has a vast array of libraries. So in version 10, which we're on version 23 now, I believe, there are 6,000 base libraries. I don't know how many are in 23. I haven't looked it up. It works on every operating system easily. It has a huge job market. And again, my main purpose is if you're going to do computer science in university, many first-year university courses use it. A few that use Python, I think you'll be fine. It's easier to go from Java to Python than it is to go from Python to Java. Again, we can learn Java because it's a powerful language, or we can learn Java because Minecraft was made in it. So was Netflix. So Java programs have 3 steps. The first step is to type a program as a Java class, compile the program, and run a compiled version of the program. I'll show you all this in just a little bit, okay? But we need to go over this background information. File storage. All files on a computer have a file extension. So like if I'm making a Word document or an essay, it's going to be .doc. If it's song, or it's a .mp3. If it's a movie, it's .mp4. If it's a video game, it's probably a .exe. A .java is a Java file. Pirate, for those of you who did Pirate, is .rar. Okay, so let's go ahead and talk about Hello World. So this is JGrasp. You should have a copy of it by now. I'm going to go ahead and create a new folder. I'm going to just call this CSEB. I'm going to open my CSEB. And I can go in here to go up 1 level, or I can make a bookmark, but I'm just going to go File, New, Java, and you're going to notice that there's not much going on here right now. So Java is the word that computer science teachers like to use has a lot of boilerplate, which I know won't mean much to you. Can I make the font bigger? It looked bigger on my other computer. I'll look it up later. Okay, hopefully you can see. If not, I'll do this, which will make it ugly, but you can at least see. So I'm going to type public class, and my class name has to be the same name as my file, so I'm going to call it Hello World. Classes start with capital letters. Curly brackets. Okay, curly brackets means everything inside of the 2 curly brackets belongs to this class. I know I'm saying words like class and you don't know what these things are yet. This is just an example. We'll break it all down, but Java has a lot of like idiosyncrasies that you won't get at first, and if I spend time just talking about them, it's going to put us further behind. So instead, just understand that there's a class called Hello World. Hello World has to be written in capital, and it's going to have to match the file name later. Okay, within that Hello World, I'm going to type public static void main string args. I think I got that right. Like, haven't coded in Java a while, and that one's always a pain to remember. Okay, and then I'm going to type system.out.println hello, comma, world. and parentheses bracket. Okay. Now, I need to save this, so I'm going to hit Control S on my computer, but I could go File Save. It's going to ask me, I want to call it hello world.java. Again, this has to match my class name. Looks good. Save it. Okay. Now, I need to compile the file, which basically is your IDE doing its work. It's turning into machine code. It's breaking the file down the proper way, so I'll hit that. Okay. I'm going to zoom out for a little bit just because we need to be able to read my compile messages down here on the bottom. And then I'll hit this guy that looks like he's running, because that's run. And as you can see, we've printed hello world. Okay, we've written our first computer program, guys. Good job. All right. So again, to make a program, we have to write it, we have to type it, we have to code it. Then we compile it. Compiling translates a program from one language to another. Whenever we compile Java, it compiles it into something called bytecode. Okay. If you notice in JClass, it created a new file called hello world.class, and this is machine language. Okay, this has nothing to do with us humans, but Java has to do this. Our IDE does this behind the scenes for us. Okay, so we compile it, and then we run it, and then the output is performed. So Hello World was started in 1970 by the people who invented the C programming language. In their first book in 1978, they explained the process, and since then, it's become a tradition for programmers. So class, I talked about class earlier. So the easiest way to think about class is a unit of code that is the basic building of Java programs. For now, all you need to know is that your code is stored in the class. Later in the year, we'll talk about how classes interact and what a class exactly means. But for now, just understand that class contains all of our other code. Right? Method. Method is a program unit that represents a particular action or computation. Think of methods like verbs, okay? If you did Pirate, we call them functions. Functions and methods are related. They're not exactly the same. Just understand in Java, I'm going to be calling them a method a lot more. Functions have more specific rules. So this is our main method and must be in all programs. This is what Java actually runs. Okay, so there's the story of Aladdin. To get into Alibaba's cave, he needed the magic word, open sesame. In Java, to create a main method, we have to remember our own magic incantation, which is public static void main strings, blah, args, blah. And you might be going to yourself, especially from someone who came from Pirate or Python, why do we need all this boilerplate? Because Java gives us a lot more control, okay? All of these keywords here are things I can change, and they do different things when I change them. It's probably going to be about half a year before we start changing them, but that's why it exists in Java. It doesn't exist in other languages. Java's just giving me a little bit more control. On top of that, to do this, we have to know this phrase. But if you use like a professional IDE that we'll use later, so just oh, I forgot the audio. Okay, so this is the IDE we'll be using later in the year. And if I go ahead and I create a new project here, I'm just going to call this one example 1. And I'll add the sample code. New window. It's all already there, so my public static void, and then I can just delete out what's inside of it and then edit it, right? Okay, so let's print. We're using println. Anyway, just showing you that like we are memorizing it now so we can see mistakes later and so we can understand it, but later it'll do it for you automatically. So seems like a waste of time now, it won't be later. Thank you. Okay, so a statement is an executable snippet of code that represents a complete command. In Java, each statement is terminated by a semicolon. So just like in English, how we have periods for speech, in Java we have semicolons. Okay, so if I want to say like Mr. Flower is the best, it's system.out.println, Mr. Flower is the best, and I have to end every line with a semicolon. Those of you coming from Pirate and Python, you're going to miss these. They're going to cause errors. You just get used to it. Okay, and string literals are anything that's surrounded by a quotation mark. Okay, so those of you who came from Pirate again, strings around them, that's a string, right? If I put a single string, a single quotation, it's not, and quotations cannot go multiple lines in Java. There is a way to do this, but we'll get to that later. All right, so we have system.out.println. This is a statement that prints a line of code on the console. It is pronounced println and sometimes called a println statement. Okay, lin in this case is print line. Okay, there are two ways to use system.out.println. I can either print a text that will give me text, or I can print nothing, which gives me a blank line. So I have this new program here, okay? And this is my new Hello World program. So let's go ahead and go through this. So what do we think this will output? I want you to pause, think, predict. Write it down. Write down the output of this program. Okay, you should have predicted the output of this program. Let's go ahead to the next part. Run. Let's test your prediction. Okay, so go ahead, put this into JGrasp, and go ahead and run your program. Did it give you the same answer, yes or no? So in our program here, we have the statement on line 1, 2, 3, 4. On line 4, that is system.out.println with nothing in it. What did this statement do? Why is there a println with nothing in it? I want you to now modify this to print your name, grade, age, and hobby, and I want you to go ahead and put that in your notes, okay? Go ahead, take 5 minutes, do that, and we will continue in the next part of the video.